Hello, everyone. Today we're going to do a packet switch of CCNA 3 version 7.12.5.13 packet switch Troubleshoot Enterprise Network. There are 5 objectives: verify switching technologies, verify DHCP, verify routing, verify WAN technologies, verify connectivity. This activity uses a variety of technologies that you have encountered during your CCNA studies, including IPv4 routing, IPv6 routing, port security, EtherChannel, DHCP, and NAT. Your task is to review the requirements, isolate and resolve any problems, and then document the steps you took to verify the requirements. The company replaced the routers R1 and R3 to accommodate a fiber connection between the locations. Okay, here is R1, R2. They replaced. This is a fiber connection. This straight red lines. These 2 lines are fiber. This Z-shape red line is serial connection. Okay, the configuration from the previous routers with serial connections were modified and applied as a starting configuration. IPv6 is being tested on a small portion of the network and needs to be verified. And here are the router 1 to 3, the 3 routers here. 3 routers here. And 4 switches, the switch 1, switch 2, switch 3, 4, these 4 switches. And actually here the switch 5 doesn't show up here in the addressing table. 4 PCs, PC1, PC2, PC3, PC4 here. All right, and the TFTP server is here. Part 1, verify switching technologies. Port security is configured to only allow PC1 to access S1's F03 interface. Okay, all violations should disable the interface. So S1 interface F03 should be configured, the port security, to only allow PC1 to access this interface F03. Let's check. So issue the command on S1 to display the current port security status. S1. Enable. And show port security. Okay, so there's nothing here. All right, that means no port security is configured on S1. So next, B, enter interface configuration mode for interface F03 and set up port security. All right, so configure terminal interface F03. Switch port security. Okay, this command is to turn on the port security on the interface F03. And the switch port, let's do like this. Switch port security and a MAC address. Okay, sticky. All right, so sticky is dynamic learned MAC address of the connected device. There's a difference between these 2 commands. The first, the switch port security is turn on the port security on this interface F03, and after the port security is turned on this interface, and ACE1 will dynamically learn the MAC address of the connected device PC1. And the MAC address will be secured automatically. But this MAC address will not be saved to the startup configuration. So when PC1 rebooted, the ACE1 will relearn the MAC address again. But the second command, the port security MAC address sticky, this sticky is dynamic learned MAC address as well, but this MAC address will be stick to the running configuration. So when we save running configuration to startup configuration, this MAC address will be saved in the startup configuration. So when we reboot PC1, ACE1, no need to relearn the MAC address of PC1. So that's a difference. Okay, so next, devices in the LAN on S1 should be in VLAN 10. This is the LAN, this LAN on S1 should be in the VLAN 10. Display the current state of VLAN configuration. Let's see the, so show VLAN brief. Okay, so VLAN brief. What's the question is what ports are currently assigned to VLAN 10? Here's VLAN 10. Here's VLAN 10. Name is V10. The ports, the F03 and F04 are assigned to VLAN 10. Okay, so next, D, PC1 should be receiving an IP address from the router R1. Router R1, PC, let's see. The question is, does the PC currently have an IP address assigned? Let's see. From here, yeah, here, PC1 has an IP address, 169.254.171.125. But this IP address is not assigned by R1. It is an automatic private IP address. It's also called APIPA address, APIPA, APIPA address, automatic private IP address. All right, so we can see from here too. So IP config. All right, so here, this address 171.1. This is automatic auto configuration IP address, so it's not assigned by R1. So the question here is current have assigned no. The answer is no. And notice G01 interface on S1 is not in the same VLAN as PC1. Change the G01 interface to be a member of VLAN 10 and set fast port fast on the interface. All right, so here, this interface is G01. Okay, I use here. Okay, G01 here, S1. This interface is not in VLAN 10. PC1 is in the VLAN 10. Okay, here G01 is where? G01 is here, is in the default VLAN 1. So we need to change G01 to the VLAN 10. That's what we need to do here. Okay, so configure terminal interface G01. Switch port access. This is access mode, VLAN 10. All right, and the spanning tree port fast. Port fast is to skip the negotiation, which is happened in spanning tree. So here is spanning tree port fast. And there's a warning, but doesn't matter, no problem. Your port fast should only be enabled on ports connected to a single host, and here, and only have effect when the interface is in non-trunking mode. So here is access mode, so it's non-trunking mode, so no problem. Okay, so we changed. Let's check here. All right, so show VLAN brief. Okay, so now this one G01, this interface changed to the VLAN 10. Good. So before G01 is in default VLAN 1. All right, so next, reset the interface address on PC1 from the GUI or by using the command prompt and the ipconfig renew command. PC1 here. Okay. So here, all right, so changed the new address. Got it. So 10.10, 192.168.10.10. This subnet mask 255.255.255.0. Default gateway 192.168.10.1. Okay, it's correct. So this IP address is assigned. It's assigned by R1. And let's go to here to check. We can use different way to check. So ipconfig renew space / renew. Yeah, 10.10, 10.1. This is default gateway. This is correct. 10.10. Here's 10.10, 10.1. Okay, good. And does PC1 has an address? Yes. Test connectivity to the TFTP server ping. So ping from PC1 to server. Ping server is 192.168.20.254. Yeah, should be successful. Yes. Yeah, let's wait a little bit. It's doing the ARP lookup. All right, yeah. Okay, successful TTL. Good. Yes, successful. Okay, so next, the LAN connected to R3. R3, okay, let me. R3 is here. The LAN connected to R3 had an additional switch added to the topology. Link aggregation using EtherChannel is configured on S2, S3, and S4. The EtherChannel links should be set to trunk. The EtherChannel links should be set to form a channel without using a negotiation protocol. Issue the command on each switch to determine if the channel is working correctly. All right, so let's go to check each switch. S2. Enable. Show Ether channel summary. Okay, so look at here. S2 has two groups, group 1, group 2. So this group 1, port channel 1, SU. SU, capital S is layer 2, capital U is in use, and the two ports configured. So, and the group 2 as well. Okay, SU, so it's good. How about S3? Enable show ether channel summary. Okay, here S3 has two groups, 1 and 3, 1 and 3. But group 1, the port channel 1 is SD. SD is layer 2, D is down. So this is down. And also no port configure. So group 3 is okay, SU and the ports. So S3 has problem. And let's check S4. Enable show ether channel summary. S4, two groups, 2 and 3, 2 and 3 group. Okay, all are SU, so perfect. So the question is, were there any problem with the ether channel? Yes, because S3 here, S3 shows the port channel 1 as down. So this port is down. Okay. Okay, HM modifies 3 to include ports S1 and F01 and F02 as port channel 1. Okay, let's do this modification. So configure terminal interface range F01-2. Okay, channel group 1 mode on. Okay, here mode on. So this configuration is mode on because we use the link aggregation, LACP, link aggregation control protocol. So link aggregation has 3 modes: active, passive, and on. Active is active negotiation. Passive is passive negotiation. On is no negotiation. So here they ask us to form a channel without using negotiation. So no negotiation, we use mode on. All right, so check the status of EtherChannel on S3. It should be stable now. Okay, let's go to check again. Summary. All right, so here, this time the group 1 port channel is SU now. So in use, the last time is SD, so changed. Stable now. So I verify the trunk status on all switches. Status trunk. So check S2. Show interface trunking. Trunk. Show interface trunk. All right, so here is trunk. S2. S2 has 3 ports. Port channel 1, port channel 2, and the G01. This is G01. G01 here. G01 here. This is G01. All right. All these ports are mode on, encapsulation 802.1q, status trunking or a trunking, native VLAN 9999, but 1. This G01 port native VLAN is wrong, should be 99, not 1. Okay, so S2 has one problem. Let's check S3. Show interface trunk. The two ports, group 1 and group 3. Group 1, group 3, both are SU. Okay, here port 1, port 3, mode on, encapsulation trunking 99 is perfect. How about S4? S4 show interface trunk. Okay, here S4 is 2, group 2, group 3, here port 2, port 3 on, trunking 99, 99. Okay, it's perfect. The question is, were there any issue with trunking? Yes, the on 3, S3 is no, H2, sorry, is S2. The issue is on S2 because S2 is using VLAN 1 as native VLAN on the link G01 interface. So that is the issue. All right, so correct the trunk issue on S2. S2, let's go to do the correction, configure terminal. Okay, interface G01, switch port, trunk, native, okay, VLAN 99. All right, so let's check. Trunk. Okay, so now G01 changed to 99, native VLAN, but before it's 1. Now it's 99, change, correct it. All right, so next is spanning tree. Spanning tree should be set to PVST plus on S2, S3, S4. S2 should be configured to be the root bridge for all VLANs. Issue the command to display the spanning tree status on S2. S2, let's show spanning tree summary totals. All right, so here, and look at here, root bridge full, root bridge full, but nothing here. This root bridge should for all VLANs, but no VLAN show up here. So it's an issue. All right, so next to the command output shows that S2 is not the root bridge for any VLAN because no any VLAN show here. So correct the spanning tree status on S2. Let's go to do configure terminal, spanning tree VLAN 1-1005, root primary. Okay, so still here, still running. Yeah, it's changing the spanning tree status on S2. Let's click again. Yeah. So check the spanning tree status on S2 to verify the change. Let's go to show summary total. Okay. So here, root bridge 4. Okay, the VLAN show up now. Here's the default. Default is default VLAN. Is VLAN 1. Here's VLAN 30, VLAN 40, VLAN 50. This native VLAN is VLAN 99. Okay, it is changed. It's changed. Okay, we finished part 1. Part 2 is verify DHCP. All right, so here, R1 is the DHCP server for R1 LAN. Here's R1 LAN. Okay, so R1 is DHCP server for this LAN. R3 is the DHCP server for all three LANs attached to R3. These are 3 LANs attached to R3. These LANs are VLAN, 3 VLANs, VLAN 30, VLAN 40, VLAN 50. Okay, so because here is only, here this is physical interface G01. But there are 3 VLANs attached to this R3. Okay, so let's go to check the addressing of PCs. PC2, okay, PC2 IP address is here, assigned by R3. 192.168.30.11. Here's the subnet mask. Here's the default gateway. It's perfect here, 3030. Okay, and check PC3. PC3 is VLAN 40. Yes, VLAN 40. So here, IP address is 40.11 here. Subnet mask. Here's default gateway. There's something wrong here. It's 192.168.168 by 40, 30. Here should be 40, 40.1. So default gateway is wrong. Yeah, let's check from here. Command prompt. So IP config. IP config. All right. So here, IP address is here, 40.11.30.1. No, it's wrong. Default gateway is wrong. All right. So S4. Oh no, it's not S4. It's PC4. IP address is here, 50.11. The subnet mask at 30. There's something wrong here too. 30 should be 50.1. 50.1, not 30.1. Okay, we check from here. So IP config. Yeah, here 50.11 30.1. So default gateway is not correct. And okay, let me do the window split. All right, so here we can, from the IP address, addressing table, the IP address we can tell. So R3, the physical interface G01, but here's a .30, .40, .50. So these 3 interfaces are sub-interface. So G01 on this physical interface, there are 3 sub-interface. Sub-interface is a virtual interface. Each sub-interface represents a VLAN. So VLAN 30, VLAN 40, VLAN 50. And this is IP address of the sub-interface. The sub-interface IP address is also the default gateway IP address of the VLAN. Okay, so 30.1, 40.1, 50.1. These 3 interfaces should be the default gateway for the VLAN. All right, so So the question is, do they all have a correct addressing? No. The answer is no. Because it's PC3 and PC4 has incorrect default gateway. Okay, B, check the DHCP setting on R3. Filter the output from the show run command to start with the DHCP command R3. Okay, let's go to show run space pipe begin DHCP. Show run? Oh no, sorry. Enable first. Show run space pipe begin DHCP. All right, here's the excluded address, IP DHCP. All right, IP DHCP pool LAN 30. Here's LAN 40. Here's LAN 50. Okay, this is the network 30. 30.1 is default. This is correct. This is 40. But this is 30.1. It should be 40.1 because 255, 255, 255 is subnet mask. So the first three octets, the number should be the same. So here's B40. A LAN 50, the 50 default router should be 50.1. Are there any issue with DHCP configuration? Yeah, default router setting is incorrect on LAN 40 and LAN 50. So next, make any necessary corrections and reset the IP addresses on the PCs. Check connectivity to all devices. So we need to do the correction. R3, no, is to do the so IP necessary correction. Yes. Okay, configure terminal. IP DHCP pool LAN 40. Okay, default router. So 192.168.40. Sorry, 40.1. Okay, here's 40.1. And LAN 50 is 50.1. There's a default router IP address. That could be the. All right, so we change the default gateway. All right, so we need to reset the IP address on PCs. So PC3, renew. Let's renew. All right, so here IP config space renew. IP config renew. Okay, here is 12, 12, 12, 40, 1241, 40.1. Okay, so let's look at here. Yeah, here 192.40.12.40.1. Yes, is changed. And the PC4 space / renew. Be easier. Yeah, here the changed 50.11 and 50.1. So changed. Before it's 30.1. And let's check from here. Yes, here 11, 50.11, 50.1. Good. Or you can do this and click the static and then click the DHCP again. So the DHCP request is successful here. This PC4 and PC3 need to static and the DHCP requesting IP address from R3 40.11 40.1. Okay, so check a connectivity all devices. Let's check. So from PC1 to ping PC2. Okay, so ping PC2 is 30.11. Okay, 30, 192, what is 30.11. So PC2, PC1 ping PC2. Success. Okay, so PC3 is 40.11. Okay, so 40.11. Success. Yes. And PC4 is 50.10. Okay, so ping 50.10. 50.10 is PC4. Success. All right. At ping the THTP server. So ping THTP server is 20.254. Success. Okay. Then let's ping the outside host. Outside host is 64.100.100.10. So it shows destination host unreachable. So there's some issue here. We're going to figure out in the future. Next, not too far future. All right, so the question is, were you able to ping all IPv4 addresses? Okay, here is all PCs were able to ping internal hosts, but were not able to ping external hosts. That is the answer. Part 3, verify routing. Verify that following requirements have been met. If not, complete the configuration. All routers are configured with OSPF process ID 1, and no routing updates should be sent across interfaces that do not have routers connected. Okay, so all these 3 routers configured with OSPF process ID 1, all right? So not sent across the interface. Oh, that means like a R1 configured with OSPF process ID 1, and this interface G01, G01, this interface is not connected to any routers, so the routing update should not be sent out from this interface. So that means this interface should be passive interface. All right, so all routers. So let's check. show run begin router OSPF. Okay, here. Okay, here's router OSPF 1. This one is process 1, process ID 1. And there's in passive interface. Okay, passive interface G001. G001 is passive interface. Okay, good. And how about R2? Enable show run begin router OSPF. Okay, here R2 is here is right, router OSPF 1, that's correct. But there are two parts. This is IPv4, but no passive interface shows here. There is a passive interface, but it is for IPv6, G00 and G01. So G01, G00 should be the passive interface in IPv4 as well. Okay, because the G01, no router connected. So this should be passive interface. G00 is connected to the interface, connected to internet. So the routing updates, it's not necessary to send to the internet. So this interface should be the passive interface as well. Okay, so this is the issue. And how about R3? R3 should run begin router OSPF. Okay, router here, R3. This is router OSPF 1 is correct. And passive, no passive interface configured here. Here's passive interface, gigabit 0150. That is for this VLAN, PC4, this VLAN. But it's IPv6, IPv4, no any passive interface. So we need to correct it. So R3, this is G01 is physical interface. There are 3 sub-interface on it. So this 3 subnet interface should be the passive interface. All right, so let's do the correction. Let's start to do R2. Okay, so configure terminal router OSPF 1 passive interface. R2 is passive interface G01 and G00. So G01 and G00. Okay. Okay. Let's go to check. All right. So here, your passive interface show up here. Good. IPv4. This is IPv6. All right, let's go to R3. Configure terminal. Configure terminal. Okay. Router OSPF 1. Okay, passive interface G01.30 is a subnet interface. Okay, and 40.50. Good. And show that again. So passive interface come out here. Good. Okay, so R2, next R2 is configured with an IPv4 default route pointing to the ISP. ISP is internet. Okay, and redistribute the default routes in the OSPF. V2 domain, V2 is for IPv4. R2 is configured with the default IPv6 fully qualified default routes, point to ISP and distribute the default route in the OSPF. V3 domain, V3 is for IPv6. Okay, let's check R3, show IP route OSPF. So show IP route OSPF. All right, so there are three. So R3, three OSPF is this network, 1 and 2 and 3. This 3 network. Okay, and show IP routes. The three OSPF, 1, 2, 3, and the C is directly connected. 1, 2, 1, 2, 2, 3, 4, 5. All right, so R3 is 1, 2, 3, 3. Oh, we're on R3. Yes. So 1, 2, 3. It's directly connected. Okay, this is 1, 2, 3, 4, 5. It's here. This is directly connected. Yeah. All right. So, and R2, R1. Show IP route. Okay. Show IP route. The default, the gateway is not set. R3 is the same. Default not set. Okay, R3. Here is OSPF 1, 2, 3, 4, 5. Okay, so R1. So 1, 2, 3, 4, and 5. Yeah, this 5 OSPF directly connected. So 1, 2, 3. So 1, 2, 3. This. Okay, all these networks are here. And R2 show IP routes. Yeah, so gateway is here. So on R2, the default route configured 0.0.0.0.0. Okay, so 3 OSPF, 5 OSPF. So it's here 1, 2, 3, 4, 5. Okay, and the direct connected is 1, 2, 3, 4. It's 1, 2, 3, 4. Okay, good. All are here. So the question is, are all the networks appear on all routers? Yes, the answer is yes. But the default route is not propagated to R1 and R3. So there's only one connectivity from R2 to internet, because R2 configured here gateway here, and from here you can tell too status followed by the asterisk. This is 000/0. This is how the default route look like in IPv4. But R1 doesn't set, gateway not set, and R3 gateway not set. That means R2 configured default route, but R2 doesn't propagate the default route information to the OSPF domain. So R1 and R3 not receive the default information. All right, so on the ping from R2 to outside, let's go to ping. From 2 to ping default from outside host here, 64.100.100.10. Success. Okay, good. Let's try again. Success 100%. Good. All right, so here, was the ping successful? Yes. Okay, the correct the default route propagation. So R2. So configure terminal. I typed too fast, sorry. And the router OSPF1. So default information originate. Okay. So this command, default information originate, is to propagate default route information to the OSPF domain. Okay, so now check the routing table of R1 and R3 to make certain the default routes present. So let's check again. All right, IP route. Okay, here. Okay, here, this default route. Gateway default route setup. Okay, good. So this 10.1.1.2 is this interface IP address. So R1 to this, to here, and to the internet. So it present R3. Let's go to check again to see here, this one, 0E2, E external. This is the default route configuration. Gateway is here set up already, but before, see, before is not set, but now set it. All right, so we did it, the propagation present. Okay, so test IPv6 connectivity from R2 to outside host and the TFTP server. So from R2 to ping TFTP server and outside host IPv4, IPv6 address, sorry, END. Okay, ping TFTP server is here, IP address 2001 colon DB8 colon B colon 20 double colon 254. Success. Okay, and then ping the outside host IPv6, ping 2001 colon DB8 colon B colon 64 double colon 10. Success. Okay, success. So R2 to this. So next is test IPv6 connectivity from R2 to PC4. PC4 is here, this one. Okay, ping PC4. Ping 2001 DB8 B 50. double column 10. Oh, something wrong. Oh, sorry. See here, there's a space. Wait, 50 to 10. Okay. Success. All right. Here's success. IPv6. So now we test the IPv6 connectivity from R3 to outside host. Outside host. Let's ping from R3 to ping 208 db8 b dot 64 dot 10. All right. 2001 db8 b dot 64 dot 10 column. It's not dot. Okay, here success rate is 0. So it's fail. It's fail. If ping fail, check the IPv6 routes on R3. Okay, be sure to validate the default routes originate from R2. Show IPv6 route. All right. So from here, we don't see any default route information here. Default route is double column /0. All right. So we need to propagate from R2. Okay, R2 configure terminal. All right, so IPv6 router OSPF1 and the default information originate. Okay, so propagate default route information. So now let's check R3 to see. Okay. All right, so this time, okay, here it shows OE2, this, so double column /0. This is how a default route look like, IPv4 default route to look like. So it presents. So the ping, now let's ping again. Ping outside host is here, okay. Success, 100%, good. All right, so part 4, verify WAN technologies. The serial link between R1 and R2 is used as a backup link in case of failure and should only carry traffic if the fiber link is unavailable. The Ethernet link between R2 and R3 is a fiber connection. Ethernet link between R1 and R3 is fiber connection. 2 and 3 is fiber. Okay, it should be used to forward traffic from R1. So from R1, the traffic should go this way. R1, R3, R2, and then go to other networks. This link is only backup. All right. So the Ethernet link, okay, here. Take a close look at the routing table on R1, routing table. Okay, show IP route. Okay. Are there any routes using the serial link? Yes. The OSPF, this one, link, serial. So on R1, this link is go to here, go to this network. Let's go through this link, serial link. And another one is 20. 20 is this network. Okay, go serial. Go to from R1 to this here and to here. And another is serial is here. Is the default gateway is from here to R2 and from R2 to internet. Okay, these three networks using the serial link. Okay, here use the trace out command to verify any suspicious path. So from R1 trace route, this IP address is server, TFTP server. So R1 to trace route. Okay, 192.168.20.254. Okay, there are two hubs. Two hubs is from R1 to R2. This is 10.1.1.2. It's this interface. And from R2 to server. This is server's IP address. So go this way. R1 using the serial link. R2 go this way. Okay, so notice the traffic is being sent via serial link, not go this way, not this way, G000. All right, so the original configurations that came from the previous serial 1 connections were transferred to the new devices. Compare the G000 interface and the serial 010 interface setting. Notice they both have an OSPF cost value set. Cost value, okay, remove the OSPF cost setting from the G000 interface. Remove the cost from this interface. Okay, it will also be necessary to remove the setting on the link on R3 that I need connect to R1. So remove the cost from this link, and we also need to remove cost from this interface because it's the two ends of this link. Okay, let's go to R1 to see. And let's to see the interface, check the cost. It's a show run. The interface S0. Okay, so S010 is here, cost 648, this interface. And the G00 is cost 648. They're the same cost. And how about R3? Should run this G010, because we're going to remove the cost. Yeah, cost 648, the same. All right, so let's go to remove the cost on interface G000. So configure terminal interface G000. Let's go to here. So here is a no IP OSPF cost 648. All right, so let's go to R3 to remove. Configure terminal interface G010. Okay, no IP OSPF cost 648. Okay, so reissue the trace out command from R1 to verify that a path has changed. Let's go to trace out. Trace out. Okay, this trace route. Okay, so now the change to 3 hops. 3 hops is from R1 to R3, R2, and server. So 1, 2, 3, 3 hops. Before is 2 hops. Yeah, before is 2 hops here, 2 hops. Now I change to 3 hops. Yes. Okay, the change has been made to direct the traffic over the faster link. However, the backup route needs to be tested. Shut down the G020 interface on R3 and test the connectivity to the TFTP server and outside host. So we need to turn off this interface to G020. So interface G020. Okay, shut down. All right, so shut down now. So this indicator, the interface light turn red. That means this link is down. Okay, so now we shut down and test the connectivity to the TFTP server. And outside, so from R1 to TFTP server success, trace roads together. But how about let's ping the outside. Ping outside 64.100.100.10. Is success rate is 0, failed. Okay, the question, were the ping successful? To TFTP server successful, but to the outside host failed. All right, so next, R2 is required to perform NAT for all internal networks. Check the NAT translations on R2. Okay, so show IP NAT translations. Okay, but nothing here. That means the NAT configuration has issue. Okay, notice that the list is empty. If you have only attempted to ping from R1, attempt to a ping from R3 to outside host and recheck the NAT translation. Okay, so ping from R3 to outside. So ping 64.100.100.10 outside host IP addresses. All right, so the ping successful 0. Okay, it's fail. All right, so here they ask us to check again, translate. Still nothing happened, still empty. All right. Okay, so issue the command to display the current NAT statistics, which will also provide the interfaces involved in NAT. So show IP NAT statistics. All right, so from here, we can see here the outside interface is G00. Here, G00 is outside interface. right? So interface, there are two inside interface, there are two. One is G01. G01 is this interface. G010 is this interface. So there should be three inside interface from this network. So GS000, but here doesn't show. So that means this interface NAT configuration missing. So we need to add. Okay, set. So here's the set S000 interface as inside interface to translate address. Yeah. So configure terminal interface S000 and IP NAT inside. Okay. So now test connectivity to outside host from R1. So let's try R1. Ping. Let's ping. This time, success. 100% success. All right. It's good. The ping should now be successful. So now we need to re-enable the interface G020, this one. So let's configure terminal interface G020. No shut down. Okay, so this indicator turned green. All right, so now part 5, verify connectivity. Devices should be configured according to the addressing table. Every device should be able to ping every other device internally. Yeah, we pinged already. Internally, the internal PCs should be able to ping the outside host. So we ping already from PC1. Let's go to ping PC1 to outside. Internal hosts we pinned already. Ping outside is 64.100.100.10. Success. Okay. And all right, so success. So PC4 should be able to ping TFTP server and outside IPv4. PC4 ping TFTP server. So ping TFTP server IPv6. Okay, IPv6 2001 colon DB8 b.20.254. Successful. Good. And ping outside host. So is ping 64 double colon 10. Successful. Okay, good. And here, I'm working on this Word document. Let's go to check the completion, 100%. Okay, 100%. So that means we perfectly finished this package troubleshoot enterprise network. So thank you for watching my video. If you like my video, please thumbs up and subscribe my channel and share with your friends. See you next time.